In this tutorial, we will dive into the concept of composition over inheritance in OOP. We will break down when to use composition, when to use inheritance, and how this design principle can help you to write more flexible and maintainable code. Inheritance is a powerful feature in OOP, allowing you to extend functionality by creating parent-child relationship between classes. Inheritance is appropriate for single-level abstract classes where we define expectation of abstract methods that must be defined in a subclass. With inheritance, we are describing exactly what object is related to each other. However, it can lead to tight coupling, making it harder to maintain and extend your code over time. Composition, on the other hand, encourages building system by combining different objects to achieve behavior. It allows for greater flexibility since component can be swapped out or reused without needing to modify the entire class structure. Composition describing what an object can do. Let's check some real-world example. Let's create a class called payment gateway. And it has a method. Here will be our payment gateway business logic code. For testing, I am just printing something. Create another class, payment processor. It will extend our parent payment gateway class. Write another method, process payment. We can get access this pay method from here like this. Let's run this code. Yeah, it's working. We can handle different type of payment gateway, something like this. Grab the gateway type. If gateway type equal to PayPal, PayPal business logic will comes here. We'll save. Gateway type equal to Stripe. Stripe business logic will be here. So let's run this. Yes, PayPal payment is successful. If we change this to Stripe and run it again, Stripe payment gateway is working. This code is okay for single payment gateway, but when we will try to introduce multiple payment gateway like this, then this code base will be unmaintainable in the long run. Also, we are violating single responsibility and open cross principle here. We'll discuss about this later on different video. This kind of problem can be solved using composition. So let's check some code to solve this. So let's create a file. This is our payment processor class. If we look back to our previous code example, then we can see we have written all of our payment related logic at payment gateway class and using it by instantiate to the payment processor child class. But for composition, it will be something different. We will create different class for different payment gateway and pass it from constructor of payment processor class. So let's create a constructor. This is our interface class and we will using it on different payment gateway classes. So let's create some classes for different payment gateway. It will implement payment gateway interface, so that we have to write this method here. All the PayPal payment related stuff will be there. Let's create the similar class for Stripe payment gateway. We need to use this here for passing dynamic object through constructor. Now we can get access of pay method of different payment gateway from this function. We can pass different payment gateway object as a constructor dependency like this. If we call process payment method here, then it should work. Let's run this. Here's it's giving output for PayPal payment gateway. Let's copy the same code for Stripe payment gateway. This is for PayPal payment, and this code block is for Stripe. If we run this, then it's showing the PayPal and Stripe payment gateway output. If we need to implement another payment gateway, let's say Braintree, then we need to simply create a Braintree gateway class. This way we can reduce tightly coupled code and extend features easily.